A river crossing site in eastern Ukraine, 11:20 hours on a recent morning. Temperature +8 Celsius with overcast skies and light rain. A river 130 meters wide with strong current. Water depth averaging 4 meters, current velocity 3 kilometers per hour. Russian engineering battalion constructing pontoon bridge to enable mechanized forces crossing. 247 combat engineers supported by security infantry battalion of 832 soldiers. Bridge construction 73% complete. 92 meters of 130-meter span assembled and positioned. Remaining 38 meters of bridge sections staged on West Bank, awaiting final assembly. Once complete, bridge would support continuous traffic of armored vehicles, including main battle tanks. An entire mechanized brigade, 2,700 soldiers with 147 vehicles, was staged 3 kilometers west, awaiting bridge completion to cross river and reinforce sector. Ukrainian reconnaissance had observed bridge construction for 16 hours through drone surveillance. Artillery fire mission was planned with precision targeting assembled bridge sections, construction equipment, staged vehicles, and personnel concentrations. The strike would commence at calculated moment, bridge nearly complete, maximum personnel and equipment concentrated at site. Mechanized brigade approaching crossing point. 14 minutes after artillery strike commenced, pontoon bridge would be destroyed beyond repair. 183 engineers would be dead, 94 wounded. Security battalion would suffer 267 casualties. Mechanized brigade approaching crossing would be struck by secondary artillery mission, causing additional 412 casualties. The river crossing operation that would enable major offensive would become comprehensive disaster, preventing operation for weeks. This happened days ago, during period of increased operational tempo. Destroyed bridge sections remain partially submerged in river. Strategic implications of Ukraine's ability to interdict river crossings through precision fires continue affecting Russian operational planning. This is what occurred during those 14 minutes when artillery destroyed months of preparation. River crossings represent complex military operations requiring extensive engineering support and creating concentrated vulnerability. Constructing bridge across major river requires specialized equipment, trained personnel, and time measured in hours or days. During construction, forces are concentrated at crossing site. Engineers assembling bridge, security forces protecting site, vehicles staged awaiting crossing. This concentration creates lucrative target if enemy can observe and engage site with precision fires. Pontoon bridges consist of floating sections supporting roadway deck. Russian PMM-2M pontoon bridge uses self-propelled floating sections. Each section is tracked vehicle carrying folding bridge deck. Sections drive into water, deploy deck, and connect to adjacent sections, creating continuous floating bridge. Standard PMM-2M bridge requires 16 sections to span 130 meters. Each section weighs 14 metric tons and requires crew of 3 engineers. Construction process is methodical and predictable. First sections enter water at near bank and position perpendicular to current. Additional sections enter water, navigate to assembly point, and connect to previous sections. Process continues section by section, extending bridge toward far bank. Final sections complete span and secure to far bank. Construction time for 130-meter bridge is approximately 6 hours with experienced crew under ideal conditions. Russian engineering battalion began construction at 0500, taking advantage of darkness for concealment. First sections entered water and assembly commenced. By 0800, 50 meters of bridge was assembled. By 1000, 90 meters complete. By 1100, 92 meters complete with only 38 meters remaining. 73% complete and projected completion at 12:30. Ukrainian reconnaissance drones had been conducting continuous surveillance of riverline for weeks, identifying potential crossing sites. When Russian engineering activity commenced at 0500, drone operators immediately recognized significance. High-resolution imagery showed pontoon sections being assembled, security forces establishing perimeter, vehicles concentrating on approaches. This intelligence was transmitted immediately to artillery planning cells. Artillery fire mission was planned with multiple objectives. Primary objective was destruction of assembled bridge sections, sinking or damaging pontoons to prevent crossing. Secondary objectives included destruction of construction equipment, casualties among engineering personnel to prevent rapid reconstruction, destruction of staged vehicles awaiting crossing. Tertiary objective was interdiction of approaching mechanized brigade to delay future crossing attempts. Fire planning allocated substantial resources reflecting target value. 36 155 mm howitzers would engage bridge site, 18 firing high-explosive rounds, 18 firing precision-guided Excalibur rounds. 12 BM-21 Grad multiple rocket launchers would saturate personnel concentration areas. 6 M142 HIMARS launchers would fire precision strikes against staged vehicle concentrations and approaching brigade column. Timing was critical for maximum effect. Striking too early meant bridge was incomplete with fewer assembled sections to destroy. Striking too late risked bridge completion, enabling vehicles to cross before strike. Optimal timing was identified as bridge 90% complete. Maximum bridge sections vulnerable, maximum personnel concentrated for final assembly. Mechanized brigade approaching but not yet crossed. At 11:20 hours, Ukrainian reconnaissance confirmed optimal conditions. Bridge was 73% complete, with final sections being positioned. Security battalion was concentrated around bridge perimeter. Engineering battalion had maximum personnel working on final assembly. Mechanized brigade had departed staging area and was approaching crossing site. Lead elements 6 kilometers distant, main body 8 kilometers distant. Ukrainian artillery commander ordered fire mission execution at 11:23. 36 howitzers fired first salvo simultaneously from positions 12 to 18 kilometers distant. Flight time for conventional rounds was 45 seconds. For Excalibur precision rounds was 52 seconds, accounting for guidance corrections during flight. Russian forces had no warning of incoming artillery. Counter-battery radar detected launches but provided insufficient warning time for meaningful response. Air defense systems were absent. Bridge site was assessed as rear area, not requiring air defense. Early warning came from sound of artillery firing, distinctive thunder of distant guns, providing perhaps 30 seconds notice before impact. At 11:24 and 8 seconds, first artillery rounds impacted bridge site. Excalibur precision rounds struck assembled pontoon sections with devastating accuracy. Each round was programmed with GPS coordinates of specific pontoon section. Rounds descended nearly vertically at terminal velocity exceeding 700 meters per second. High explosive rounds weighing 46 kilograms detonated on impact with pontoon decks. Explosions punctured aluminum pontoon hulls, destroyed bridge deck structures, killed crews aboard sections. Pontoons designed to support vehicle weight couldn't withstand direct artillery hits. Punctured pontoons flooded and sank within seconds. Bridge deck sections separated from damaged pontoons and were swept away by current. Of 92 meters of assembled bridge, 68 meters was destroyed in first minute of bombardment. 14 pontoon sections were sunk or catastrophically damaged. Bridge deck separated into fragments floating downstream. The hours of construction were obliterated in seconds of precision artillery fire. Engineers working on bridge sections were killed by blast effects and fragmentation. Crews aboard pontoons during impact had no protection. Open deck configuration meant personnel were completely exposed. High explosive detonations killed crews within 50-meter radius through fragmentation and overpressure. Some engineers were blown off bridge sections into river, drowning in current while wearing heavy equipment. Conventional high-explosive artillery engaged personnel and equipment concentrations on banks. Forward observers directed fires using drone observation, providing real-time correction. Rounds walked across assembly areas where engineers were preparing remaining bridge sections for deployment. Equipment was destroyed. Bridge transporters, construction vehicles, power generators all disabled by fragmentation or direct hits. Cluster munitions from Grad launchers saturated security perimeter positions. Each 122mm rocket delivered 37 fragmentation submunitions dispersing across 100-meter area. 12 rockets released approximately 440 submunitions across security positions. Infantry in shallow fighting positions suffered heavy casualties from submunition airbursts, delivering fragmentation downward into trenches. Security forces attempted response, but artillery continued without pause. Officers tried to organize withdrawal, but communication was disrupted by ongoing explosions. Vehicles attempting to evacuate became targets for precision strikes. Infantry attempting to withdraw on foot were engaged by continued artillery saturation. At 11:27, 4 minutes into bombardment, HIMARS precision strikes engaged staged vehicle concentration 3 kilometers west. Mechanized brigade vehicles were positioned in assembly area awaiting bridge completion. Intelligence had identified concentration through drone reconnaissance. 6 HIMARS rockets with unitary high-explosive warheads struck command vehicles, ammunition trucks, and fuel tankers. Command post vehicle was destroyed in first strike, killing brigade commander and staff. Ammunition truck detonated, creating secondary explosion, destroying adjacent vehicles. Fuel tankers created massive fires spreading across parking area. Within 2 minutes, organized command structure was eliminated and fires were consuming staged vehicles. Additional HIMARS strikes engaged mechanized brigade column approaching on road 6 to 8 kilometers from crossing. Lead battalion on road was struck with precision. Command vehicles identified through signals, intelligence were engaged, first eliminating leadership. Infantry fighting vehicles carrying dismounted troops were struck, causing mass casualties among embarked infantry unable to escape burning vehicles. By 11:37, 14 minutes after strike commencement, artillery fire mission was complete. Allocated ammunition was expended, objectives were achieved, Ukrainian artillery positions were being displaced to prevent counter-battery response. Assessment showed comprehensive destruction of crossing operation. Pontoon bridge was destroyed, 68 of 92 assembled meters were sunk or damaged beyond repair. Remaining sections were separated and drifting downstream. Current had swept debris kilometers from crossing site. Bridge was total loss, requiring complete reconstruction with new equipment. Engineering battalion casualties were catastrophic. 183 engineers confirmed dead from artillery strikes and drowning. 94 wounded, requiring evacuation. Equipment losses included 14 destroyed pontoon sections worth approximately $4 million each, $56 million total, plus construction equipment and support vehicles. Security battalion suffered 267 casualties, 143 dead, 124 wounded. Unit was combat ineffective, requiring withdrawal and reconstitution. Perimeter security collapsed, allowing Ukrainian reconnaissance to approach destroyed crossing site for damage assessment. Mechanized brigade casualties from HIMARS strikes totaled 412, 231 dead, 181 wounded. Brigade command structure was destroyed, requiring reorganization. 15 vehicles were destroyed, including command vehicles, ammunition carriers, and fuel tankers. Brigade was delayed minimum 2 weeks for reconstitution before operational capability could be restored. The tactical impact was prevention of river crossing, eliminating Russian ability to reinforce threatened sector. Forces on East Bank remained isolated without reinforcement or resupply via bridge crossing. Offensive operations planned for Eastern sector were cancelled due to inability to mass forces. Strategic impact was demonstration of Ukrainian capability to detect and destroy river crossing attempts through integrated reconnaissance and precision fires. Other planned crossings were cancelled or relocated based on vulnerability demonstrated at this site. Russian offensive planning was constrained by inability to guarantee successful river crossings under Ukrainian observation and fire coverage. Russian engineering analysis identified multiple failures. Construction occurred without adequate air defense coverage of site. Counter-battery assets weren't positioned to suppress Ukrainian artillery. Construction proceeded on predictable schedule, allowing enemy planning. Concentration of forces at single crossing site created vulnerability that should have been mitigated through dispersion or deception. Ukrainian execution demonstrated sophisticated integration of capabilities. Continuous drone reconnaissance provided early warning and targeting data. Artillery planning allocated appropriate assets for target value. Timing was optimized for maximum effect. Precision fires achieved devastating accuracy against point targets. Conventional fires saturated area targets effectively. The integration created synergistic effect, far exceeding sum of individual capabilities. The economic analysis showed extraordinary cost-benefit ratio. Ukrainian artillery expenditure was approximately $2 million. conventional rounds, precision rounds, rockets. Russian losses exceeded $80 million. Pontoon sections, vehicles, equipment, plus casualties representing trained personnel requiring months to replace. Ratio was 40-1, favoring Ukrainian investment. Recovery operations at crossing site were dangerous and largely unsuccessful. Current had scattered debris across kilometers of river. Pontoon sections sunk in 4-meter depth were difficult to locate and recover. Bodies of engineers who drowned were swept downstream. Some recovered days later, kilometers from crossing site, others never found. The river itself became obstacle for recovery. Strong current and high water level made operations difficult. Divers couldn't work effectively in current and low visibility. Recovery boats struggled against current. Weather complicated operations. Rain increased water level further. Wind created dangerous conditions for small boats. International observers studied engagement as demonstration of modern precision fires capability against engineering operations. River crossings traditionally required hours, providing time for enemy interdiction. Modern construction methods accelerated timelines but couldn't eliminate vulnerability during assembly. Precision reconnaissance and fires could destroy crossings even late in construction process. Environmental impact was significant. Destroyed vehicles leaked fuel and lubricants into river, contaminating water. Aluminum pontoon sections contained toxic materials. Unexploded ordnance scattered across site created ongoing hazard. Chemical contamination would persist for months, affecting downstream water quality. Families of dead engineers demanded explanation for why construction proceeded without adequate protection. Why was site exposed to observation? Why wasn't air defense provided? Why weren't forces dispersed to reduce casualties? These questions created political pressure that has not been satisfactorily answered. The numbers define river crossing catastrophe: 247 engineers deployed, 183 dead, 94 wounded, 68 of 92 meters of bridge destroyed, 14 pontoon sections lost, 412 additional casualties in staged brigade, 14 minutes from first round to mission complete, 80 million in losses. River crossing prevented indefinitely. This is modern warfare, where precision fires destroy concentrated engineering operations, where 14 minutes eliminates weeks of preparation, where river crossings remain among most vulnerable military operations. Welcome to warfare, where pontoon bridges become death traps, where artillery precision makes river crossings nearly impossible, where 14 minutes of fires prevents major offensive operation.